Hey guys, LegoFin here, and today I'm going to try my best and explain to you how this calculator that I've built quite a while ago works, functions, and maybe even how you can build your own one. Alright, so before I'm going to explain to you exactly how this works, just a little disclaimer. I won't be explaining everything in too much detail, simply because that would take ages, and yeah. Also, if you're watching this, I hope you have some basic knowledge about binary. And yeah, now let's start off right with the input. Alright, so the first problem we are facing is, how do we create a 2-digit binary number out of a 2-digit decimal input with only one row of inputs, basically, reaching from 0 to 9. So basically, if we want to create the 34, we press the 3 and then the 4. And the way we do that is, at first, wait, let me reset it so you can actually see it. Basically, each time we press the 3, it creates a 3 in binary, so this should be the 3, yeah. It creates a 3 in binary, which is 1, 1, as simple as that, And also the 3 in binary, no, the 30 in binary, so that's 0, 1, 1, 1, 1. Not too interesting. Wait a second, actually it should be... No, never mind me. And what we do with that is we control which of those, so if either the 3 or the 30 should go through into the system. And we do that with these pistons over here. And they are toggled each time we press any of those buttons. So even if we press the 0, which is this button over here, which doesn't actually have a corresponding line, as you can see, it still toggles this flip-flop, and therefore the 10 is basically created, and now those pistons are down, and the signals can get stored inside our knowledges over here. And once both signals are created, so we have the 30 and we have the 4, they get added by this gray part, which is simply an adder. So we take the 40 in binary, no, the 30 in binary, and the 4, and we add them, and then we get a 34 as an output. And it's exactly the same over here, so I used some command block magic, and therefore copied and pasted this whole contraption over here. And yeah, once we are done with creating the first number, all of those pistons retract, if they wouldn't get butted sometimes. And those pistons go down and enable the creating of the second number. Alright, so once we have created both numbers, then we simply add them. So basically this is the entire core of the system, this blue part. That's the adder. And yeah, it adds both of the created numbers, so that 34 and 17, I think. And yeah, it basically adds them. The problem is, this is a binary to decimal, yes, converter, but it's a special one, as you will later on see. And it's not like this purple one, which simply checks for the combination of the input lines and gives an output, depending on that. So like, when we have 1, 0, 0, 1, that's one combination, which is 9 in binary, and so we get the last torch, which is corresponding for the 9. But it's not as easy, because if you would do this, so this is for 10 numbers, ranging from 0 to 9. And now imagine you have this for 200 numbers, then it would get huge, and so this is what this black part later on does. But as already mentioned, it would get broken if we were to simply let the signal pass through, because anytime any number is put into here, let's say we generate the 30, then this would already give out a 30 and put it into the adder, and that would break it. And therefore we use this orange control circuit, which is basically a bunch of torches that, even if those torches would be off, will still keep this redstone line powered. And therefore the output will only go through if this orange part activates, or activates over here, which is when we've added the very last number. Okay, and let's move on to the most complicated part of this build, which actually took the longest time to build. So when everything else around it was finished, this is the part where I got stuck. And even after I finished it and I built the part beyond that, it still wasn't working properly, and yeah, this is what caused the most problems. But anyways, it mostly works now, and the way it works is actually quite simple. So when we, as already mentioned, put the output of this adder into there, into this black part, we only do it with a short pulse. And let's say we have the number 51, I think it was, and we put it into this machine. Then it will save it with these errors knowledges. And this black part might look familiar to you, because it's actually an adder, but it's inverted, and that makes it a subtractor. And also the output is inverted, so that's what these torches are for. And these lamps are simply indicator lights for debugging it. And so whenever we put a number into it, say the 51, it gets stored in those errors knowledges, and the 0 will be subtracted from it, and so it will display 51. But then there was this part over here, which is basically a clock that generates a short pulse. And every time this clock cycles through, it subtracts 10 from the subtractor with these redstone lines over here, which simply get powered, because that's the only thing we ever want to retract from it, which is 10. And so it the output will be 41, and that will go into these torches. And as you might have noticed, at first it's 51 and then it's 41, and so yeah, these torches and these redstone lines over here, they will change constantly until the output is actually 41, then they will stay that way. And that's what those pistons are for, because only at the correct time, when everything is subtracted already, these pistons will pull up the blocks and yeah, make the 41 as a binary number. They will save it into these repeaters, and while they are basically saved in these repeaters, we reset these errors knowledges, and yeah, then we put the new number into it, which is the 41, and then the whole cycle starts through until we are at a number which is below 10, and we detect that in two ways, which with an AND gate. The first part is it can't be greater than 16, which should be really obvious, and that the second part is that it has to be recognized by this decoder, which gives an output from 0 to 9. So even if it's even if none of these lamps above 16 and including 16 are powered, we can still have a number greater than 10, for example 8 and 4, which is 12. But as already mentioned, it won't get recognized by this decoder, and so this part of the AND gate won't be powered, and so this the clock won't get stopped. And also every time this clock cycles, it sends a signal through into this way up here, into this line of pistons, so you get that nice animation while the clock is cycling through and it's still processing the number, that you get this line effect, if you know what I mean. And yeah, that's basically how this machine works, this binary to decimal encoder. Now that you know how everything down there works and basically how the number itself gets processed, we still haven't done anything of the display, so let's do that now, which and this is what all this stuff above is for. So we start with a number generated, let's say the 30, and that's what those pistons down here are for. So basically when we have the 30, which is this, we get a special combination kinda pushed up through these pistons and into these redstone lines, and then there's the decoder for numbers from 0 to 90, so in 10 steps, if you know what I mean. So this is 10, 20, 30, etc. And that simply goes into this thing. And yeah, that's really simple, but all it does is if you power a line, it shows a number, and yeah, that's really all it does. And it does that for the corresponding combination of binary digits basing on this, if you know what I mean. And it's the same for every number, so if, even the second 0, that's a little bit simpler because we only have these 4 pistons to create the numbers from 0 to 9. And it's the very same with this over here, it's again copy and paste it, and then there's just a lot of boss lines that look really awesome in my opinion, and those go down to the second part, so the lower piston display. And for the result display we've done something a little bit different. So for the number on the right, it's simply the remains of this decoder. So when the number is 51, it will have retracted 10 5 times, and then the number will be less than 10, which is 1. So the 1 will only stay powered in this machine, go through into this decoder, which will tell the display part over here, which is basically exactly the same as above, that it has to display a 1. And over here we just count how many times we have subtracted 10. So every time we subtract 10, which is when this comparator will power, it will go through and power those subtractor parts, but it will also power this line, which will tell this counterpart to count up by 1, and this counter is really easily done with repeater locks. And that's also why it flashes so funky when we reset it, because it has to count through all of these, and once it's at the beginning again, then we know that we have reset it successfully and we can stop. Yeah, basically how the resetting works is we turn this off so the repeater signal can go through, but once it reaches the end it will tell this hour's knowledge and stop resetting. And yeah, that's how the display works, and that's how everything works, and I hope you understood everything. In case you have any questions, please feel free to leave a comment down below. And as always, thank you for watching, and I'll see you next time.